Today, our group, which is Group 3, will be presenting the title of fermented meat. Let me explain some of the backgrounds of fermented meat and sausage. Basically, fermented meat is a type of dried meat that has been prepared and dehydrated according to specific techniques. The production and consumption of fermented meats expanded throughout Europe in the Middle Age and were adapted to climatic conditions. For example, smoked in Northern Europe and dried in Mediterranean countries. When considering fermented meats, the most common type is sausage. A sausage is a type of meat product usually made from ground meat, often pork, beef, or poultry, along with salt, spices, and other flavorings. The word sausage comes from the Middle English sauci, which came from sal, Latin for salt. In French, they are saucisson, and in Germany, Wurst. Next, there are many forms of sausages including hot dog, pepperoni, bologna, and salami. Generally, sausages will be used in various dishes such as stew, sandwiches, and many more. And they also can be eaten as whole pieces, or they can chop up as already cooked pieces. And now, they are ready to eat sausages, which can easily get from any convenience store. Next, I will pass to Amir Shafirul for microorganisms and raw materials involved in fermented meats.
Next, we will learn about the microorganisms that involved in the fermented sausage process. So there are three main microorganisms that involved, which is lactic acid bacteria, yeast, and nitrate-reducing bacteria. Lactic acid bacteria is important to lowering the pH by producing lactic acid from sugar fermentation. So, it can improve the final product firmness and cohesiveness. The example of lactic acid bacteria is Lactobacillus sakei and Lactobacillus plantarum. Next, moving on to the yeast. They are important to form a mold that can film the surface of the sausage, which make them to prevent excessive dehydration and can be saved longer and improve the flavor of the product. The example is the Baryonychus hansenii and Penicillium nigricans. And lastly, the nitrate-reducing bacteria, which is significant in formation of distinctive red color of the fermented sausage, so it will be more attractive to the customer. The example of the nitrate-reducing bacteria is Staphylococcus psilocyst, Staphylococcus coronacea, and Staphylococcus epidermidis. Next slide. We'll be looking on the taxonomy of microorganisms, and the example I have been chosen is Lactobacillus sakei, Penicillium nigricans, and Staphylococcus psilocyst. On this slide, we'll learn about the taxonomy of microorganisms. So, the example that we chosen is Lactobacillus sakei. Next is yeast, Penicillium nigricans, and nitrate-reducing bacteria, Staphylococcus psilocyst. So, there are a lot of raw material and media composition used to produce a fermented sausage. However, what in this slide is one of the main ingredients, which is beef, calf, poultry, myofibril protein, fat from animal, salt, water, vitamin C, sugar, specifically dextrose, and spice, herb, and seasoner for the taste.
We need to know that the biochemical pathway of the meat fermentation is lactic acid bacteria fermentation, which is known as lab fermentation. So, there are two types of lab fermentation, which is homolytic and heterolytic. So, in homolytic, it involves the conversion of one glucose molecule into two lactic acid molecules. Meanwhile, for the heterolytic, it involves the conversion of one glucose molecule into the lactic acid molecule, carbon dioxide, and ethanol. So, in homolytic, it involves homofermentative bacteria, which can convert glucose into two molecules of lactate. For the heterolytic, it involves heterofermentative bacteria, that are able to produce less lactate and less ATP. So, in homolytic, the bacteria that are involved is Lactococcus and Lactobacillus. For the heterolytic, the bacteria that are involved is Lepomostoc, Bacilla, and Eurycoccus. So, as you can see at the bottom of the slide, you can see there are two equations for each fermentation. For homolytic fermentation, there are one equation at the bottom, and for the heterolytic fermentation, there are one equation at the bottom. As you can see, from the equation of homolytic, we can see that one glucose molecule become two lactic acid molecule. For heterolytic fermentation, one molecule of glucose become one lactic acid molecule plus ethanol plus carbon dioxide. So that's for me. Move on to the next part. Thank you.
Now we will go on with process condition. So the first one is bacterial fermentation, which is addition of lactic acid bacteria in the process of fermented sausage. So the example of the lactic acid bacteria is Lactobacillus, Staphylococcus, and Coria species. So these microbes will convert sugars into other compounds such as acids, gas, and alcohol. So this will help to control the pH and inhibit bacterial growth in the meat. So the second one is addition of chemical additive. There are two examples of chemical additive used in the production of fermented sausage, which is nitrates and phosphate. So nitrates is used to slow cure the meat and provide protection against botulism. Second one is phosphate, which improve the water binding capacity in the meat. So the lastly we have yield and productivity. So to produce a healthy fermented sausage, we need to produce a high level of conjugated linoleic acid, or we call it CLA, in the meat. So, but how to increase the level of CLA in the meat? We need to use more reliable enzyme or more powerful enzyme like Lactobacillus plantarum. So there are the things that we could do to increase our yield and productivity of the fermented sausage is controlling the meat pH, fermentation temperature, time, the amount of fatty acid, and the starter culture dose. So at the bottom is the example of optimized for sausage production in the food industry.
Hello, today we're gonna look at how to make fermented sausage. I'm gonna show you step by step on how to make it. Here we go. First of all, it is important that the meat is fresh and of high quality, has a lean ratio to the right fat, and has a good binding properties. The meat should be clean and free of bacteria and other microbes. In other words, the meat used to produce sausage must be safe. Next, use a meat grinder to efficiently grind the material. During this grinding stage, the meat components are broken down into small, uniformly sized particles. Minced beef is the main ingredient in sausage. The next step in making sausage is the selection of seasoning, and it is important to combine them in the right amount. Meat is mixed with all salt, spices, and complement each other to create a satisfying product. This is followed by a mixture of meat and non-meat ingredients. The concern is that the manufacturer carefully controls the mix of meat and non-meat ingredients to achieve the desired properties for a particular sausage formulation. Place the meat and non-meat ingredient in a meat blender and mix thoroughly. For example, flavors, salt, and other ingredients should be mixed throughout the sausage formulation. After mixing is complete, the mixed material can be packaged in a bag or extruded into a casing. This process is called stuffing, and a sausage stuffing machine is the equipment needed to stuff a type of sausage. After that, put the ready sausage into the fermentation chamber. The fermentation step rapidly lowers the pH, stabilizes the product, and prevents the growth of Staphylococcus aureus during this high temperature process. After fermentation, the goal when drying sausage is to dry them inside out. If it dries too quickly, the protein crust on the surface will prevent moisture from escaping from the inside. If it is too late, there is a risk of yeast and mold growing on the surface. At the beginning of the drying process, the relative humidity should be kept higher up to 98%. As the sausage matures and the water activity of the sausage declines, the humidity needs to be reduced. But some manufacturers allow mold at first to help evaporate in the middle of the sausage and finally wash it away. The relative humidity of the drying room should be kept 3 to 5 points lower than the room humidity. Maintaining a slight airflow also helps. Finally, this is the final result after all the process have been done and ready to eat. That's all for this part. Thank you.
So, we proceed with advantages meat to people, plant, and profit. Advantages meat to people is meat are important because for the human body, because meat can provide all the necessary nutrients. For example, the body needs amino acid for the synthesis protein needed for daily survival. There are many amino acids that cannot be produced by the body itself to get amino acid. So, to obtain amino acid from the body is from meat. Next, advantages meat to plant is meat is consistent, is also more environment friendly as modern beef production founded since year 1097. Advanced its production have produced 30% more beef with 30% fewer animals according to a Washington State University study. Moreover, 40.2% of household gas emission claims are from livestock farming, with beef accounting for 1.4% according to the Environmental Protection Agency. For the profit, for the profit, meat is very important to economy, and meat can be big business. The global industry is worth of $2 trillion, and the world's largest meat company make over $50 billion in annual revenue. Next, application meat to people, planet, and profit. Applications in the meat industry are available to two different applications where enzymes are used to improve the manufacturing process and upgrade the quality of meat. The application is the softening of overly hard meat parts and the restarting of fresher, more valuable, and high quality piece of meat. To improve the tenderness of poor quality cuts or cuts such as those from aged animals, the protein of the connection tissue, mainly collagen, should be the target of the proteolysis.
There are a few challenges that we will face throughout the production of fermented meat. The first challenge is slow fermentation of meat. This occurs due to the frozen culture allowed to thaw and subsequently held too long before dispensing into meat, and this will cause microorganisms exhaust nutrients, reduce the pH value, and hence lowering the culture activity. Next, during produced fermented meat, we will also face the challenges of fast fermentation of meat. This is because the temperature and humidity during fermentation is higher than normal. Moreover, the third challenge that will happen during the meat fermentation is the fail of meat fermentation. This will occur when there is no non-compliance with recommended handling temperature after thawing of meat, because any bacteria that may have been present before freezing can begin to multiply rapidly. There are also some strategies can be proposed to improve the meat product quality. First, the addition of the dietary fibers to meat products able to enhance the meat product quality. Next, the adding of antioxidant to meat product can improve the meat quality. Furthermore, the salt reduction of meat product is essential to make the quality of meat product better.